Good morning. Here we are going to start the Cauchy's problem for first order partial differential equations, and we are going to discuss what the Cauchy's problem is, what are the conditions, right? Now the first point is, suppose x naught mu, y naught mu and z naught mu. These are the functions which along with their first derivatives are continuous in the interval, the open interval AB, where this mu is lying in this open interval. The value for mu is strictly greater than a and strictly less than b. Then the another point is, suppose f of x, y, z, p and q. This is the continuous functions of x, y, z, p and q. So f is a function of all these variables, where this p is what? This p is partial derivative of z with respect to x, and q is partial derivative of z with respect to y, right? So if this function, which is depending upon these variables, is a continuous function of x, y, z, p and q in a certain region u of the x, y, z, p, q space, such that the partial derivative of f with respect to q into derivative of x naught with respect to mu, because x naught is a function of mu, so we are derivating x naught with respect to mu, minus partial derivative of f with respect to p into derivative of y naught with respect to mu. This should not be equal to 0. Please remember this condition, it is very important. Then there exists one and only one function phi xy and a region R in the xy space with the following properties, and now we are going to study the properties. First property is phi xy and its partial derivatives with respect to x and y. Partial derivative of phi with respect to x is represented as this. Partial derivative of phi with respect to y is represented as this. Phi is the function of xy, right? So phi and its partial derivatives with respect to x and y are continuous functions in R. Second property, for all xy in R, the point x, y, phi xy, the partial derivative of phi with respect to x and the partial derivative of phi with respect to y, this point lies in U, and the function depending upon x, y, phi and its partial derivatives is 0, right? Third point, marking this property as 1. Third, for all mu belonging to the open interval AB, the point x naught mu and y naught mu, this point x naught, y naught, which is depending upon mu, this point belongs to R. Phi of x naught mu, y naught mu is equal to z naught mu. Alright, next is the geometrical interpretation of Cauchy's problem. If the conditions A and B are satisfied, what are the conditions? If the condition A and B are satisfied, that is, if x naught, y naught, z naught are functions which along with their first derivatives are continuous in this interval, where mu is lying between A and B. If this condition is satisfied and also this condition is satisfied, then there exists a surface z equal to phi xy which passes through a curve tau such that x equal to x naught mu and y equal to y naught mu and z equal to z naught mu. And at every point of tau, the direction pq minus 1 of the normal is such that f of x, y, z, pq is equal to 0. Right? Next is a remark. The crux of the Cauchy's problem is given by, given a partial differential equation f of x, y, z, p, q equal to 0 and a curve tau such that x equal to x naught mu, y equal to y naught depending upon mu, z equal to z naught, where mu is belonging to the open interval AB. Marking this problem as 2. The Cauchy problem is to find the solution z equal to phi xy. We need to find the solution z of this problem of 2, right? Such that z naught mu is equal to phi x naught y naught, where x naught is depending upon mu and y naught is also depending upon mu, for all mu belonging to the open interval AB. In other words, the integral surface z is equal to phi xy contains the initial data curve tau. When we need to solve the example based on the Cauchy's problem, then you need to understand better. Here is an example. State the properties of phi xy if there exists a surface z equal to phi xy which passes through the curve tau with the parametric equations x equal to x naught, y equal to y naught, z equal to z naught, and at every point of which the direction p, q, negative 1 of the normal is such that f of x, y, z, p, q equal to 0. So for this, you have to state the properties 1, 2 and 3 of the Cauchy's problem. You have to state the properties, right? These one. This first, that is phi xy and its partial derivatives are continuous functions in R. Second, for all xy in R, this point lies in U and the function is 0. And third property, for all mu belonging to the open interval AB, the point x naught y naught belongs to R and phi of this point is equal to z naught, right? So you have to state these three properties. And in the next content, we are going to solve the example based on the Cauchy's problem. Okay, thank you. Stay blessed. Have a nice day.